are always on the ends of the expressions. Then we're integrating x squared with respect to x, which is dx. So I've got to integrate 1 over y dy is equal to the integral of x squared dx. From here, I can integrate the left-hand side and the right-hand side. So the left-hand side integrates to ln y. The right-hand side, add 1 to the power, divide by the new power, which is x cubed over 3 plus c. And that is how we integrate using separating the variables. Now, this is a general solution at this stage here, but often we need to rearrange this to find a function for y. So to get y on its own, we need to do the opposite to ln y, which is e. So we're going to take e of both sides. So y is equal to e to the power of x cubed over 3 plus c. Now from here, I can use the rules of indices. Now x to the power of a times by x to the power of b is the same as x to the power of a plus b. So I can separate this out to be x to the power of x cubed over 3 times by e to the power of c, because when I add these powers together, that is the rules of indices that we have done at GCSE. So x to the a times by x to the b, x to the a plus b. You can just separate it out going backwards. From here, I've got a constant. So e to the power of any number is just going to be a constant. So we can replace this constant of e to the c with a capital letter of a. So my general solution is y equals a e to the x cubed over 3. A is just a general term that we use to express a different constant. So this e to the c has a value of a, so we can just write it here. I'm now going to show you some tips when integrating. So if you have got a function where you have got 2 things in the numerator and 1 thing in the denominator, you can split this up into 2 fractions. Okay, so think of this as being x over x minus 1 over x. So you can see here I've got 1 minus 1 over x because x divided by x gives me 1. From here it is now easy to integrate. We know the integral of 1 is just x. We know the integral of 1 over x is ln x, which means my answer is going to be x minus ln x plus c. Remember to always add your c when you are integrating. My next tip is if we've got a fraction where I've got the same power in the numerator here, like an x over an x in the denominator. So I've got x over x minus 1. So in this scenario, we're going to use long division because we've got a top-heavy fraction because the power here is the same as the denominator. So when I divide, I'm going to be divided by my divisor, which is underneath term, the denominator, so x minus 1. That goes outside the front of the long division. And then the thing that I'm going to divide by is the x, which goes in under the bus stop. So I'm going to say how many times does x minus 1 go into x? So x into x goes once, so that gets written at the top. Then I say 1 times by x, which gives me x, which goes underneath, and 1 times by negative 1 gives me negative 1. From here, I've got to subtract these values. So I've got 0, subtract negative 1, which is going to be the same as 0. 2 minuses make a plus, so 0 plus 1, which is just going to be 1. And x take away x is 0. Now we write this as my quotient, which comes here at the front, and my remainder 1 gets written as the fraction. So what's left over? 1 out of this x minus 1. This is what is left. From here, I can now integrate. So the integral of 1 is just x, and the integral of 1 over x minus 1 is just ln of the denominator, which is x minus 1, divided by the differential of the x, which is just 1, which is just divided by 1, so it doesn't make a difference, plus your constant c. Remember to always add c when you're dividing and you're integrating. My last tip we're going to look at is to integrate something where I've got a squared in the denominator. So I've got 1 over x squared minus 4. Now in this scenario, we're going to use the difference of 2 squares, then we're going to use partial fractions. Now the difference of 2 squares splits this into 2 brackets, where the brackets are exactly the same except one has got a plus sign and one has got a minus sign. So when I use the difference of 2 squares, I'm just going to get x minus 2 and x plus 2. So we're going to be integrating this with respect to x. Now we're going to look at partial fractions. So when I use partial fractions, I say that this fraction I've got here is equivalently equal to a over x minus 2 plus b over x plus 2. So then I can say that 1 is going to be identically equal to a times by x plus 2. So I multiply my a by my x plus 2 to make my denominators exactly the same. Plus b times by the x minus 2, so multiply this opposite diagonal together. So the denominators of both the fractions will be exactly the same, and these x minus 2 and x plus 2 on both sides can disappear. So I've got 1 is identically equal to a times by x plus 2 plus b times by x minus 2. Now the easiest way to find the values of a and b are to let x equal different values. So I'm first of all going to let x equal to minus 2. Now if I let x equal minus 2 plus 2 gives me 0. So on this first term here I get 0. Then I've got plus b times by minus 2, which is going to be minus 2 times by b, which is minus 4. So b will be equal to minus 1 over 4, or minus a quarter. Then I'm going to let x equal to 2. So substituting 2 in, this second bracket will become 0. So I've got 2 plus 2 in the first bracket. 2 plus 2 is 4. Divide by 4 gives me a quarter. So a is going to equal a quarter. So I now know my value of a and I know my value of b. So I can separate this fraction here as one combined fraction into two separate fractions. So I'm going to get a quarter of x quarter times by 1 over x minus 2 minus 1 over 4 times by x plus 2. Now you could take these quarters outside the front of the fraction if you find it easier to integrate, or just think of them as a constant at the front. So you've got a quarter times by 1 over x minus 2 minus a quarter times by 1 over x plus 2 will help you when you integrate. Now, the integral of 1 over x minus 2 is just ln of x minus 2. The quarter, as I said, was a constant, just stays out the front. The second one has got a fraction of or a factor of minus a quarter, again, which just comes out the front. And then we're just integrating 1 over x plus 2, which is going to be ln of x plus 2. Remember in each case to divide by the differential of the x terms. In this case, it's just 1, so it doesn't make a difference. Always add plus c when you are integrating. If you found this video useful, please share, like and subscribe so we can all get great at maths.